Hi, folks. So now we'll discuss what really is a computer language. As you might recall, the purpose of language is to communicate information. The same it is for a computer language as well. So what does a computer language do? It communicates information to the computer, right? So what this means is that it has to communicate something, some information to the computer. That is what languages do. And what exactly that information might be, right? So that information is a sequence of instructions that computer understands, right? So it's information. The purpose of language is to communicate information. Here we are communicating it to the computer. So it has to be in a language that the computer understands. Otherwise, it would be like somebody talking in Spanish to another person who understands only English. There would be no communication, even though a language is being used. So both parties who happen to be communicating with each other have to at least agree on some common language, right? All right, so since we are dealing with computers now, so there needs to be some common language that the computer understands, and using that language, we can talk to the computer. All right, so more specifically, these are instructions in a language that computer understands, and inside the computer specifically, these are instructions that the processor understands, right? So the processor or microprocessor is a complex chip, right? Like piece of electronics. Let's say it is this guy, or we can write it against. All right. So a microprocessor or a processor, as you might like to call it, let's say if this is a processor. All right. So let's say there is some language that it understands, and that language happens to be, for any processor, it happens to be the machine language, all right? Machine language is a language that the processor, the specific processor, understands natively, right? So what could words in those language look like? So they are sequences of ones and zeros. So let's say there is some 4-bit computer, and these are some instructions of where did that will come from. So let's say these are some instructions. We write 3 instructions over here. Let's say this instruction means, so now remember, language also conveys meaning, right? So what meaning to impart to this 1001 will be up to the designer of this processor, right? So meaning is imparted by designer, right? So it is designed in that. All right. So let's say for the sake of discussion, this instruction means add, this instruction means subtract, and this instruction means increment, let's say. Right? All right. So remember, the computer is, this processor is just a piece of electronics. It does not understand anything like we do. Any meaning has to be imparted by us. So let's say the processor, the guy who designed this processor, said, all right, this sequence means add, this sequence means subtract, this sequence means increment. And you know, this processor in turn is part of a large computer system, like a typical computer or a laptop would be, or even a server. This processor would be connected to other elements like, you know, different controllers, memory, you know, controllers, RAM, memory, etc., other things. So why this is important, that when you're designing the entire computer system, it is important that the other elements in the computer system talk to the processor in the language the processor understands, and they all agree that when given this instruction, the processor will do something, and that something is add, so on, right? So this is what a machine language looks like. And as you can tell, it's very cumbersome to, for a human to program a processor using a bunch of ones and zeros. And there has to be a better way. Well, there is. The way is C. All right. And there are, of course, other ways too. And we'll continue this in another video. Take care. Bye.